So before you were going from moles to grams. And what that meant is you had to do a moles to moles conversion from one compound to the other. And then once you got to your desired compound, then you were able to use your molar mass in order to go from moles to grams. Well, now we're going to be doing it the reversed way. So you're going to start out with grams. In order to get from grams of one compound to moles of another compound, you actually need to get to moles of your first compound. So you're going to start out using your molar mass first, and then you'll do your mole ratios in order to figure out what your moles of another compound is going to be. Okay? So let's try this first problem out together. So what if I ask you to calculate how many moles of iron 3 oxide is needed to produce 11.38 grams of iron? Well, again, as always, let's pull out our important information. So your starting point is going to be the 11.38 grams of iron. Now what we want to do from here is our destination is going to be moles of iron 3 oxide. So our first step we're going to have to do is we're going to have to use our molar mass. Anytime you're going from grams to moles, you're always going to start out with your molar mass of your starting compound. So we're going to figure out what our molar mass is of iron. So when you look at your periodic table, you're going to notice that iron is going to have an atomic mass of 55.85 grams. Now, I don't have to multiply that out by anything because there's only one iron present. Again, remember, you don't have to look at your coefficients at all. Your coefficients are only important when you're using your mole ratios, okay? But when you're doing your atomic mass and you're trying to figure out what your molar mass is going to be based off your atomic mass, you're just going to multiply that number based off a subscript. This has an understood one subscript. So I have 55.85 grams of iron for every 1 mole. Okay? So remember, your molar mass is going to have a unit of grams per mole. So in this case here, for iron, it was 55.85 grams for every 1 mole. And I just plugged this in accordingly up here. But this time the grams ended up on bottom because I needed the grams to cancel out. And so that 1 mole ended up being up on top. Okay, so once I've converted from grams to moles of iron, now is the time that I'm allowed to go from one compound to the other compound. Again, using your mole ratio. So what we're going to do is look at our mole ratios. I need moles of iron to be on bottom so it cancels out. I look up here, I see I have a 2. So I'm going to put 2 moles of iron on bottom. And then I need to get moles of iron 3 oxide up on top. I look at iron 3 oxide, I have an understood 1 coefficient. So that's going to be 1 mole of iron 3 oxide. My moles of iron cancel out, leaving me at my destination of moles of iron 3 oxide. So from here, all I have to do is now do the calculations. When you go forward and you do your calculations, you should end up with 0.1019 moles of iron 3 oxide. And remember, I put my answers using significant digits. Your starting point had 4 significant digits, 1, 2, 3, 4. My answer was given with 4 significant digits, 1, 2, 3, 4. Not too bad, right? Pretty easy peasy. Alright, so as always what we're going to do is I'm going to pop up a slide up here for you to practice. Pause it, practice the problem on your own please, and then restart the video to see how you did.